I welcome you all for this presentation. In this presentation, we are going to discuss about Introduction to Computer Networks, that is just stepping into our course. And in the last presentation, we discussed about the learning objectives, then the course outcome, then what are the text and reference books to be followed. All those things we discussed in the previous presentation. This is the overview of this presentation, that is what is computer networks and why computer networks is needed for communication. Next, local area network, then metropolitan area network, wide area network, then applications of networks, then network topology, network components, followed by summary of this presentation. This presentation is just giving an introduction to computer networks, the base or foundation for the computer networks. First, what is computer networks? All of you are familiar what is computer networks, and nowadays all are using the computer network, so you are familiar with that. But anyway, first stepping into our course, we need to know the definition of the computer networks. So computer network connects two or more autonomous computers. You know the meaning of autonomous. What is autonomous? Individually, independently, it can do something, that is autonomous. We know autonomous institution. Autonomous institution means they can independently decide something, that is the meaning. So here autonomous means independently the computer can perform some task, that is autonomous computers. So here computer network means two or more autonomous computers are connected, and the computers, the autonomous computers are physically presented anywhere, that is located geographically, it is located anywhere. Because now I am taking class and you are listening, but we are not in the same place, we are in different location, but you are just hearing. If I am taking a class, it's of a recorded video, but if we are taking live class, at that time we are connected together, but we are not in a same location. We all are scattered, we all are in different location. All the 53 students are at different location, myself is in different location, but we all are connected, but we are geographically located anywhere, but we are connected. So this is the basic thing of the computer network. So the computers can be geographically located anywhere, and what we are calling as a network means it consists of some set of devices. Each and every device we calling it as a node. So if you are attending a class, some of you may be keeping your laptop and you are attending the class. Some of you are having your desktop computer and you are attending the class. Some of you are having your smartphone and you are attending the class. So different devices are involved. All these set of devices, those devices we are calling it as nodes. So there is a connection between the nodes. Network means there is a connection between nodes. Set of devices are involved, that is nodes are involved, and they are connected through communication link. If it is a wired communication, some wires are there. Some wireless communication, we are having some form of wireless form, that is the communication link is available. Later on we can learn what are the transmission media available to connect the devices. So how we are connected? Through some communication links, whatever may be the form, but some link is there between each and every people. All the students are connected and faculty is connected. So here we are forming a network, because I can see you, you can see me, whatever I am speaking you can listen to that, and if I ask something you are speaking, others can listen. So we are connected, and we are connected through some link only, some communication link is there. And node can be a computer, printer or any other device capable of sending and receiving data generated by other nodes on the network. Suppose if we are having a lab in our college, that is in our lab, we are having a lab, means at that time all the devices are located in one place, and through wires each and every devices are connected to the network. In the lab we all are using a computer, different computers or different devices we are using, and each of us are connected through a network, and there we are having how we are connected through some communication communication link. Some physical link is there between the devices. But now the case is different. We are placed in different location, but we are connected through different communication links. Not the physical, not the wired way, wireless means of communication we are having. So the node can be a computer, printer or any other device nowadays. This is the old definition. Nowadays we can include the smartphone as well. Any device capable of sending, that is only any device capable of sending, receiving data generated by other nodes on the network. And I already said you that the link can be a cable, wired cable is there. If in the laboratory setup we all are connected through a physical cable, then here optic fiber or any medium which can transport as signal carrying information. So this is the example of a computer network. See, some connecting device is there. Here in a computer, a printer is connected, computer printer is connected. So if we need to take printout, we can take. We are sending, we are communicating with the printer. Just we are sending a message to the printer, it will print. That is that is computer to printer. And here some connecting device is there. It may be a hub or switch or router, anything we can have it. And the other computers are connected through that. So router is involved means in between we are having a router. The hub is there, switch is there. So based on the network, whether it is a LAN or a WAN or MAN, based on that, this intermediate device may vary. Okay. So each and everything is connected through some link. So this is about what is a computer network. Next, why computer networks? We studied the definition of computer network, but why we need computer networks? Because in order to provide data communication, if you want to communicate something to others, in such case only we need a network. That is how we can communicate. Earlier days we have a postal service. We just write a letter, we post it in a post box. Then the postman will collect all those things, and by seeing the destination address, the letter is passed and given to the receiver. It reached to the receiver. But nowadays, all of a sudden, if you want to communicate with another person, all of a sudden we can communicate. So mainly the need for computer networks is for data communication only. And data communication means we are exchanging the data between two devices via some form of transmission medium such as a wire cable. Nowadays we are having wireless also, wireless communication also. So here the main components of data communication, or 5 components are involved. First one is the sender. Because without a sender, if I want to send something to you, then only there is a need for data communication. If I don't want to send anything to you or don't want to convey anything to you, whether the communication happens, no, not needed, right? So if I want to send something, or if I want to convey some message to you, in such case only we need the data communication. So in order to have the data communication in an effective manner, we need a computer network. So the first component of this data communication is the sender. So sender is a main thing, sender. This is the first component. Next, whom we are sending to. I need to convey a message to a particular student. So I am just sending a message to one particular student. Or in the class, if I am posting an assignment, so everyone has to take, I need to send a message to all of you. So I am just broadcasting it, or through a group mail I am sending you the question like that. So I am having a receiver. Whoever sender knows the receiver also, then only he can send the message. So the sender is one of the component, the receiver is another component. Then what message we are going to send, that plays a vital role. So third component is message. Message, without message, simply I am sending means anyway I am just sending you a message like hello or hi. Anyway message is involved in that. Suppose I am sending a blank mail to you. At that time also something you can get it. Without a message, some message has received. Likewise you open and see no message is there. But anyway, something is involved in that. So message is the main thing. Whatever the things we are going to convey, that is the message. Another thing is medium. The fourth one is the medium. Medium in the sense how the message travel from sender to receiver through some communication link or through some path only the message is communicated. So the medium plays a vital role. And finally the protocol. Protocol in the sense we have some set of agreed rules. I am sending one message to you. That message must be understandable to you. If the message is not understandable to you, what is the meaning of sending that message to you? It's of no use. So the data communication fails. So if I am speaking in English, if you don't know English, this communication has failed, because whatever I am speaking, you are not able to understand. What is the meaning of listening to that? That is of no use. So the protocol is also important. So in the communication or in the computer networks, how the protocol works means the humans, we are just sending some text message, but the machine can't understand that message. Whatever we are sending, it is converted to a digital form, then our machine readable form, then that machine readable form is only transmitted to the receiver side, and in the receiver side the machine readable form is converted to whatever the form I send. So some set of rules are followed. Without following some set of rules, we can't receive the message, or the receiver can't receive whatever the message sent by the sender. So the protocol also plays a vital role. That is the fifth component. So 5 important components are important available in the data communication. One is the sender, then receiver, then message, then the protocol. Next is the medium. Then the communication must be of different types. That is, we are having simplex communication, then half duplex communication and full duplex communication. Simplex communication means the direction of data is only one way. That is, only I can send the message or I can receive the message. Any one way only possible. It is like a one-way path, because only we can send or we can receive. Not both the things are possible. Say for example, I am having a keyboard. What is the purpose of the keyboard? The keyboard is just give the input. To give input to the computer only we are having the keyboard. Whether the keyboard receive anything from the computer wherever it sends? No. Only the keyboard sends computer input to the computer. So keyboard is a type of simplex way of communication. Only the direction of data of send is only one way. Another thing is the monitor is there. The monitor can receive something from any device. Whether the monitor will send something to a device? No, it just receive. Whatever we are giving, it just receive and display it. That's it. So this is also an example for simplex communication. Another thing is half duplex. Half duplex in the sense, two ways of communication is possible. Two direction we can send the data, but not at the same time. At a time, only one direction only works, and afterwards the next direction will work. So here you see direction of data at time 1, station 1 to station 2, and the next direction of data at time 2, station 2 to station 1. So here at a time some walkie talkies, police and all will have some device, right? So they can at a time both he can't receive and he can't send. Only one thing is possible. He can get the information, and if needed after that he want to tell something means, so only one way is possible. At a time one thing is possible. That is, one way communication is possible. That is half duplex. The third one is full duplex. It is also called as duplex communication. That is direction of data at all the time. Say in our phone conversation and all, generally if you follow the half duplex, the data communication is a efficient, happen in a efficient manner. One person is speaking and another person here, and afterwards he or she will reply. That is a good way of communication. But generally what we used to do, if I am talking something, if you want to at that time something you think means, immediately you also speak. So both of them are speaking simultaneously, but both of them hear it. So that is a full duplex communication, or it is called as duplex communication. So these are the three different ways: simplex, it is only one direction of data flow taken in only one direction. Half duplex, data flow taken in both the direction, but not at the same time. At a time, only one direction of data communication is possible. Full duplex means data communication taken both the direction at the simultaneously. That is possible in the full duplex. So the need for computer networks is to communicate the data. For that only we need computer networks. So how we are communicating the data, that only we are going to discuss in this course. Next is the local area network, metropolitan area network and wide area network. So these categories of network are based on the location, how the network is connected. So a network in a small geographical area, that is in a room or building or in a campus, we call it as a local area network. It is for short distances and it is designed to provide local interconnectivity. For that only we are having the local area network. Next is network in a city is called a metropolitan area network. That is, it is designed to provide connectivity over areas such as city. If the network is having connection in a city, then we call it as a metropolitan area network. So it is somewhat high than the local area network. Next is the network spread geographically, that is country or across globe, is called as a wide area network. It is the connection in a long distance, that we call it as a wide area network. And this wide area network is designed to provide connectivity over large areas. So based on the size of the area, we can divide or we can categorize the network into local area network, metropolitan area network and wide area network. Next, mainly the applications of networks. Where and all we are using the networks. One thing is for resource sharing. For sharing the resources, we can have the networks. Nowadays, we are utilizing based on the advancement in technology like cloud computing, fog computing, edge computing and all. Many things are easily available. No need to have all the costly resources in one particular place and we can have to access. Many things we are not having, we are having the distributed processing and we feel that everything, all the resources are with us. But that is not exactly the meaning. We are just sharing something based on the cloud is providing various services. So we are sharing many of the resources. What and all the things we are sharing means hardware, that is the computing resources we are sharing, then disk, printers, many hardware, whatever the hardware infrastructures we are sharing. Nowadays we are not having, nowadays we are doing some GPU computing and all we are performing, but not necessarily we have all the full setup in our home or in a college. We can get it by paying some percentage of amount, we can get it. Whatever the things we needed, for that alone we can pay and we can use the infrastructure available. So it is for resource sharing. Another thing is software, application software. Nowadays many open sources are available. So we are just sharing the softwares. Another thing is information sharing, that is we can share the files, databases. Easily we can share from anywhere, we can share the files databases. Now we are having, if you are having, if you are storing the data, that is we are just preparing a document and having it in the cloud. If you are going anywhere, you can access that the document, you can do all the workings and all in the document. So everything is shared. Then search capability, that is we are having the www, World Wide Web we are having, that is for information sharing. Next, coming to the communication, we are sending email, then message broadcast, we are sending many things we are doing. Then remote computing we are working. Then distributed processing, the grid computing, the also computers, the networks is applied up. So nowadays in this pandemic, we are thankful for this computer networks because due to the advancement in technology only, now it is possible to, without coming to the college also, we can have the classes. We are doing something without wasting the time, right? So thanks to the advancement in technology, so that we are managing in whatever the situation, we are sharing something and we are doing our day-to-day activities in an efficient manner. So these are some of the applications of networks. Next is the network topology. Network topology in the sense how the computers are connected. So different ways of connection is possible to have the computer networks. So network topology defines the way in which the computers, printers and other devices are connected. That is, it describes the layout of wire and devices as well as the paths used by data transmission. We are having many different topologies like bus topology, then ring topology, then star topology, then extended star topology and mesh topology. So this names comes based on the structure the devices are connected. So let us see one by one all the topologies. First is the bus topology. It is commonly referred to as a linear bus. Why it is called as bus topology means all the devices on the bus topology are connected by a single cable line. Here we are having the main cable line. In the main cable line, each and every computers are connected as a single node. So only this is called as bus topology. Just we are entering into a bus and we are utilizing the link. That's it. Okay, so this is the bus topology. It is called as a linear bus topology. Next is star topology. In this star topology, we are having a center node. So all the other nodes are connected to the center node. Suppose the center node fails, what happens? The communication fails. So there may be some disadvantage of each and every topology. So mainly this star topology is used in Ethernet LANs. So when installed, this star topology resembles spokes in a bicycle. So only the name, it just by looking into the structure, it looks as a star. So only the name star topology. Next is tree topology. This tree topology is extended version of a star topology. You just see without the branches, if you see these are the branches. Without the branches, if you see, this is called as a star topology only. So with the branches, it is called as a tree topology. So larger networks use the extended star topology, also called as a tree topology. This is used with the network devices that filter frames or packets like bridges, switches, routers. And this topology significantly reduces the traffic on the wires by sending packets only to the wires of the destination host. Each and every topology is having their own advantage and disadvantage. Suppose if you are having or if you are a designer of a computer network, based on your application, you have to choose the topology. Next is the ring topology. Here a frame travels around the ring, that is stopping at each node, and if a nodes want to transmit, it adds the data as well as the destination address to the frame. That is in the ring topology, not all the devices send the message at the same time. So what happens means, if any node needs to send a message, at that time one token is circulating in the ring and the node wants to send a message, has to request the token. So if it is having the token, then only it has to send the message. So those things in detail we will be studying later. Some methodology are there for that in the token ring and all. At that time we will study that. So here the frame then continues around the ring until it finds the destination node which takes the data out of the frame. And here also we are having two categories. One is the single ring. All the devices on the network share a single cable. See here only single cable is shared between all the nodes in the ring. Next is the dual ring. The dual ring topology allows data to be sent in both the directions. Both the direction we can send. This is a different flavor of the ring topology. Next is the mesh topology, mostly used. That is, it connects all devices to each other for redundancy and fault tolerance. I already told you that in the star topology, if the sender node fails, the communication fails. So in order to overcome that, in order to have this fault tolerance facility in the network structure. We are having this mesh topology. Mainly this mesh topology is used in WANs to interconnect LANs and for mission critical networks like those used by banks and financial institutions. Because banks, the financial institutions plays a vital role. That is, if the communication fails, the many huge amount may get lost. So there they need the redundancy as well as fault tolerance. So in mission critical applications and all, this mesh topology is used. Implementing the mesh topology is expensive and difficult. So it is somewhat complicated only, but in order to have the fault tolerant facility, we are going in for this mesh topology. Next is the network components. All those things in detail we will be studying later. So some of the network components are the physical or networking media, then interconnecting devices, then computers, then networking software as well as applications. These are the basic components of a network. So physical media, the networking, the means by which the signals, data are sent from one computer to another. Some communication link. What media is used for having the communication link? There may be twisted pair. This is one example for the twisted pair only. So how the cable is connected. Here we are having outer jacket, overall shield, then pair shields, twisted pair. Inside that only we are having the wire. So how many levels of security is there, you see here? So why we are having these much levels of security? Because in order to have the connection in a secured manner. Suppose if you are just having the twisted pair, the phone connection, earlier we had the landline connection. At that time the phone connection, if you see, means there they use this different layers of security. Because if you are directly using the wires, then it gets easily affected, easily tampered. So that is not a secure form of communication. For that only, in the twisted pair, here we are having different shields to secure it. In the media, we can see what is the configurations and all of each and everything. In the coming slides, coming classes, we can see that in the transmission media. Next is networking devices, because we are having hubs, switches, routers, wireless access points, modulator, demodulator, modems, all are there. Not all the computers are connected by means of switches, hubs. In each and every layer we are having various networking devices, hubs, switches, routers, wireless access points are there. So from that only we are connecting all the devices. So what are the working principle of all these devices, and in which layer which device is used? Later on we can see that. Next is computers. We know the famous architecture, that is client server architecture. So the client get the service from the server. The basic client server architecture. Here we are having a server and many clients are connected to whatever the services provided by the server can be utilized by the clients. Because in the server, in our institution also, one main server is there. The server's computing facility is more compared to the client's computing facility, and in the server only we are having more things. The configuration is also very in the server, because it provides more computing facility. And in the client server network arrangement, network services are located in a dedicated computer whose only function is to respond to the request of clients. So the server's functionality is to respond to the clients, and the server only all the files, print, application, security and all the services in a central computer that is continuously available to respond to the client request. Generally in institutions and all, we are having a very big server room. So that server room we used to safeguard more compared to the normal systems. So why we are safeguarding the server means there we are having more facilities, more high-end configuration is there. In addition to that, the cost of the server is also high compared to the client machines. So the server is the only job of the server is respond to the client. So the server must be in a position to have all the services needed for the client. Say for example, if it is some institution, educational or academic institution, the server is different. If it is a bank, the working principle of the the services in the server is different. So based on the facility, the server may vary, but whatever the need of the client, that must be satisfied by the server. Next is networking protocol. Mainly we see the TCP/IP protocol only it is used. So it is having the network interface, network transport and application layer. This is the layered architecture of TCP/IP. So if some application is given, the application in the sense we are having the file transfer protocol, then email, remote login, many things are available. And in the transport layer, we are having the protocol like TCP, UDP, and in the network, we are having the ICMP, ARP, RA, RP, RIP, all those things are there in the layer. Mainly, the elements of the protocol are the syntax and semantics and the timing. That is, syntax means the structure or format of the data. That is how the protocol is reading the bits that is given in the syntax. Some basic syntax must be followed. Next is semantics. Semantics means the meaning, how to interpret the bits. For that only we are having the semantics. Then timing, when data should be sent, because there may be a timing. Suppose a mail is sent today, it must be received immediately. If it is received 3 days back, what is the meaning? The timing plays a vital role in the communication process. So when the data must be sent and what it is sending and what is the speed at which it is sending, that is very, very important. So the networking protocol is also one of the components. Next, coming to the applications of this network, applications of this networks, that is we are having email, then websites, e-commerce, news groups, video conferencing, chat groups. Many things are there nowadays. Many more applications are there. So these are about the network components. So here in this presentation we discussed about what is computer network, what is the need for computer network, different categories of computer network like LAN, MAN and WAN. Then we have seen about the complete applications of networks. Then we discussed about the various network topology, how the network is connected, that is the structure of the network. Next we discussed about some of the components of networks. In the next presentation, we will be discussing about the layered network architecture. Thank you.